In this video, I will be showing you how to solve a separable differential equation initial value problem. Let's get started. First, we have our problem, which is y prime is equal to x times y cubed times 1 plus x squared to the negative 1/2 power. It is important to note that this can be written as dy over dx is equal to x times y cubed divided by the square root of 1 plus x squared. This is because negative exponents are the same thing as dividing by another positive exponent. Our initial condition is y of 0 is equal to 1. Let's get started. First, we have find the solution to the initial value problem in explicit form. Explicit form means that we have y of x, which is equal to a solution which only contains terms of x. First, we have dy over dx is equal to x times y cubed divided by the square root of 1 minus x squared. First, we are going to divide both sides by y cubed in order to get our terms on both sides of the equations. This is the separating part of the separable ordinary differential equations. Now we have 1 divided by y cubed times dy dx is equal to x divided by the square root of 1 plus x squared. Next, we want to multiply both sides by dx so that we can integrate. This becomes 1 divided by y cubed times dy is equal to x divided by the square root of 1 plus x squared times dx. Now we can integrate. It's important to note that this problem cannot be solved directly. For the right-hand side of the equation, we will need to use u substitution. For this, we're going to set our u equal to 1 plus x squared, and that makes our du equal to 2x dx. For our problem, we know that the dx which is given is equal to 1/2 the du, because our dx is x times dx, which is 1/2 2x dx. Now we are going to substitute this into the equation by plug and chugging. Here we have the integral of 1 divided by y cubed times dy is equal to 1/2, which can be pulled outside of the integral, times the integral of 1 divided by the square root of u, du, which is equal to the integral of y to the negative third power dy, which is equal to 1/2 the integral of u to the negative 1/2 times du. Here, all we have done is flipped our positive exponents into their negative exponents. Now it's time to integrate with our powers. It's important to note that the integration with powers rule is that the integral of x to the nth power times dx is equal to 1 divided by n plus 1 times x to the n plus 1 power plus c. This rule also applies to negative exponents. Now we have the integral of y to the negative third power times dy is equal to, or becomes, 1 divided by negative 3 plus 1 times y to the negative 3 plus 1 power. This becomes negative 1 over 2y times y to the negative second power. This is equal to 1/2 times the integral of u to the negative 1/2 power times du, which becomes 1/2 times 1 divided by negative 1/2 plus 1 times u to the negative 1/2 plus 1 power plus c. Here, I have included the c only on the right-hand side of the equation. This is because if I included c on both sides, two random constants subtracted from each other creates another random constant. Next, this becomes 1/2 times 1 divided by 1/2, which can be simplified to 2, which cancels both the 2 and the 1/2 out, times u to the 1/2 power plus c. Now we have negative 1/2 times y squared is equal to the square root of u plus c. Simplifying, this becomes negative 1 divided by 2 times y to the second power, which is equal to the square root of 1 plus x squared plus c. Here we have substituted our u back into the equation. Now we need to solve for y. We are going to multiply both sides of the equation by negative 2 in order to isolate the y squared. This leaves us with 1 divided by y squared is equal to negative 2 times the square root of 1 plus x squared plus c. Again, because negative 2 times a random constant is equal to another random constant, we simplify this to just c. Now it's time to take the inverse of both sides. This leaves us with y squared is equal to 1 divided by negative 2 times the square root of 1 plus x squared plus c. Taking the square root of both sides, we have y is equal to plus or minus the square root of 1 divided by negative 2 times the square root of 1 plus x squared plus c. It's important to remember that plus or minus sign because anything that is squared can be positive or negative when you take the square root. Now it's time to solve the initial value part of the problem, or IVP. Y of 0 we know is equal to 1. This means that when y is equal to 1, when x is equal to 0. Now we're going to set our equation equal to 1 and set x as equal to 0. Therefore, 1 is equal to plus or minus the square root of 1 divided by negative 2 times the square root of 1 plus 0 squared plus c. 0 squared is equal to 0, and the square root of 1 is equal to 1. Therefore, we end up with 1 is equal to plus or minus the square root of 1 divided by negative 2 plus c. Now we know that since 1 squared is equal to 1 and the square root of 1 is equal to 1, the only possible answer for this equation is where 1 divided by negative 2 plus c is equal to 1. Therefore, 1 is equal to negative 2 plus c, after multiplying both sides of the equation by negative 2 plus c, and therefore c is equal to 3. Now when we put that back into the equation, we find out that 1 is equal to plus or minus 1 divided by negative 2 plus 3. This both acts as a way to check our work, but also, and more importantly, determines whether we are using the positive or the negative square root for this equation. Here we are able to determine that it is positive, as the square root of 1 is automatically 1, and then we would have to apply a negative, which we do not since our answer is positive. Therefore, y of x is equal to positive square root 1 divided by the negative 2 times the square root of 1 plus x squared plus 3. Part B. Plot the graph of the solution. Let's start by making a standard x and y table. Here we have negative 2, negative 1, 0, and 1. Plugging negative 2 into the equation results in 0.824i, I for imaginary. This is because negative 2 times the square root of 1 plus x squared plus 3 is less than 0. This makes our function underneath the square root negative, and therefore our numbers become imaginary. Plugging in negative 1, we get negative 1 is equal to 2.414. We already know what y of 0 is equal to, which is 1, as that was our initial value. Finally, we plug 1 into the equation, which we get again 2.414. We expect this graph to be symmetrical because the x term is squared and the function is to the 1/2 power, eliminating negatives. This means that we would expect positive 2 to not give us an answer. We also know that this means that this function is always going to be on the positive side of the x-axis, because when we square a function, we can never receive a negative number. Now C. Determine the approximate interval in which the solution is defined. We already know that negative 2 gives us an imaginary number, so where is the asymptote? Well, we know that we cannot divide by 0. So first we set our denominator, or negative 2 times the square root of 1 plus x squared plus 3, equal to 0. Solving, we get 1 plus x squared is equal to 9/4, and Finally, x is equal to, or cannot be equal to, plus or minus the square root of 5/4, which is approximately equal to plus or minus 1.118039. Therefore, y of x is defined on the interval negative square root of 5 divided by 4 is less than x, where x must be less than the square root of 5 divided by 4. Thank you.